The software development landscape we're navigating today, heading into 2026, it's just fundamentally unrecognizable compared to, what, 5 years
It,
ago?
it really is. Think about it. A 5-year-old code base now feels like ancient history.
Totally. Built before we really knew what large language models could do.
Exactly. And now we've got AI writing, what, almost half the code.
Yeah, it's incredible. And new languages focusing on memory safety are challenging standards that have been around for decades. Plus, architectures are shifting faster than ever, mostly trying to manage the complexity we created.
That speed, that rate of change is really the defining thing right now. If you're a tech leader or, a developer just trying to keep
Or
up,
someone making those big strategic tech investments.
right, you just don't have the bandwidth to sift through hundreds of industry reports, benchmark studies, developer surveys. They land every month. It's overwhelming.
And that's exactly our mission today. We've done the sifting. We've distilled all those key signals from GitHub stats, TIOBE trends, Stack Overflow sentiment, all of it, into one comprehensive deep dive.
We're basically giving you the shortcut, the essential knowledge to understand the entire modern software stack, what's driving adoption, what's falling behind.
Yep. And we're structuring this deep dive around really three seismic shifts that define this 2026 stack.
Okay, so first up, the human element. The rise of augmentation, how generative AI is fundamentally changing the developer's job.
Right. Second, the language landscape. The winners, the challengers, those legacy systems still hanging on.
And finally, we'll dig into architectural rebalancing, moving past that micro-everything fatigue.
And the infrastructure layer that supports it all, especially focusing on serverless AI and the rise of internal developer platforms.
Sounds like a plan.
Okay, let's unpack this, starting with what's arguably the most transformative thing in software development history, this human-AI collaboration. How is it actually redefining what it means to be a developer today?
Well, the quantitative impact. It's not just theory anymore. We have hard numbers, and honestly, they're pretty astonishing.
We're way past simple autocomplete now, aren't we?
Oh, absolutely. These AI tools are acting more like full development partners, often taking the first crack at entire features.
And the data backs this up.
Dramatically.
Yeah.
Current reports show that, get this, 41% of all code is now initially generated by AI.
Wow. 41%. That's nearly half the global code base being synthesized by an automated partner.
It's not a niche thing anymore. It's mainstream reality.
Okay, so what does that mean for speed? How much faster are we actually moving? I saw some data. Implementation times for standard features dropped significantly.
Yeah, from an average of about 18.3 hours down to just 7.9 hours when using these generative AI tools.
Okay, that's a massive drop.
And that kind of reduction feeds into a huge 34.7% reduction in development cycles overall across the enterprises measured.
That's almost a third faster.
Right. But the really interesting part is where that efficiency comes from. It's hitting the mechanical, repetitive stuff the hardest.
Okay, give us some specifics. Where's the AI really doing the heavy lifting?
So look at the numbers. Raw code generation productivity, up 55.8%. Debugging time, which, used to just eat up engineer hours, that's down 37.2%.
That's significant. Debugging is often the hidden time sink.
Exactly. And refactoring that tedious but necessary work of restructuring code, we're seeing code quality metrics improved by 41.6% when AI assists.
And what about CROD? That term it's thrown around. There was a big reduction there too, right? Something like 51%?
Yeah, a 51.7% reduction in time for CRO'd implementations.
Okay, for listeners who maybe aren't building enterprise apps daily, quickly, what is CROD and why is AI so good at it?
Sure, CRE just stands for create, read, update, delete. The 4 basic things you need to do with data in almost any database-backed app.
Like saving a user profile, getting a blog post.
Exactly. Editing an order, archiving an old record, stuff like that. Structurally, these operations are almost identical across countless applications.
Right. Very pattern-based.
Totally. They need knowledge of database schemas, APIs, serialization, but not much novel creative thought. It's rote work.
So perfect for AI automation, boilerplate elimination.
Precisely. It's where AI shines right now.
Okay, that's immense efficiency. But here's my sort of critical question. If AI is writing 41% of the code, handling all this boilerplate, doesn't that just mean developers, especially seniors, are spending way more time reviewing potentially dodgy code? Is this just shifting the bottleneck to code review fatigue?
That's a crucial point, and a really fair challenge. The human role does change drastically. The focus absolutely shifts upstream.
Okay.
Developers are realizing they can now spend 67.8% more time on those higher-level creative critical tasks.
Like what specifically?
Architectural design, digging into complex business logic where the company's real IP lies, and really refining the user experience.
Hmm. So the AI handles the how, and the human gets pushed to focus harder on the what and the why.
Exactly. The argument is it's not just faster output, it's higher leverage output. It forces the human brain onto the truly strategic problems.
Interesting. And is this actually making developers happier, less drudgery?
Well, contrary to some early fears, the data suggests yes. This shift correlates with an increase in job satisfaction for, I think it was over 84% of developers surveyed. They feel they're doing more meaningful, creative work, less repetitive coding.
Okay, so speed and job satisfaction are up. That's the bright side. But we have to talk about the flip side, the non-negotiable need for human oversight, quality, security. This is where the risk is, right?
Absolutely. This is where we need significant caution.
Mm.
The speed gains are real, but human judgment, still non-negotiable, especially in regulated sectors like healthcare, finance.
Yeah, you can't just let AI rip in those environments.
No way.
Yeah.
Our sources showed that even with AI help, solutions in those areas needed an average of like 3.2 human review cycles before passing deployment audits. The human check is still paramount.
And the risk isn't just theoretical, it's quantifiable and, frankly, a bit scary.
It is. One data point that really stood out, 42.7% of AI-suggested code implementations contain potential security flaws.
Nearly half.
I
That's unsettling.
It gets worse. When that code touches sensitive operations, authentication, session management, input validation,
The really critical stuff.
right, the vulnerability rate there jumps to a horrifying 61.3%.
Over 60%. Wow.
If AI code is that unreliable on something as fundamental as authentication, it really suggests our current human guardrails might not be enough for the sheer volume of code being generated. It's a massive, frankly terrifying cost-benefit analysis right there.
And who's making these mistakes? Is it across the board, or are junior devs more susceptible?
The data points pretty clearly here. Junior developers, let's say 0 to 3 years experience, they're 2.4 times more likely to incorporate that vulnerable AI-generated code than senior folks.
Why is that? Just trusting the output too much?
It seems so. They tend to trust the suggestion because syntactically it looks correct, it compiles. But they lack that deep experience, that skepticism, that domain knowledge that seniors use as guardrails, that human expertise is absolutely vital.
And it's not just security flaws, right? It's also about context. AI models are great pattern matchers, but they often miss the bigger picture, the specific business rules or history of a complex system.
Precisely. The latest Octoverse report highlighted this. 73.4% of AI-generated code lacks true contextual understanding of the broader business requirements.
So it compiles, passes unit tests, maybe.
Right. But it fails on the subtle domain-specific logic. It gets the syntax, misses the strategic intent. Only about, 34.2% success rate in capturing domain logic correctly. And for complex architectural decisions, those tricky trade-offs between cost, latency, scaling AI systems only handle about 29.4% successfully.
Okay, so the human architect, the domain expert, still absolutely essential for the high-level calls.
Indispensable.
Yeah.
Which leads to the good news, maybe.
Yeah.
We're not seeing mass elimination of developer roles. It's more an evolution. It's something more specialized, higher leverage.
So what do these new roles, these new skills look like in 2026?
Well, the industry is shifting roles, not just cutting them. Workforce reduction directly tied to AI is actually pretty low, only 8.7%. What's really booming are the skills needed to manage this AI partnership and, crucially, validate its output.
And this is where it gets really interesting, right? Entirely new disciplines are emerging, commanding premium salaries.
Absolutely. Prompt engineering, that's the fastest growing skill set right now. A massive 342% increase in job postings mentioning it.
342%.
Insane growth. And this isn't about writing code directly. It's about effectively explaining a business problem to an AI, describing the what and the why, not just the how.
A communication skill almost, bridging business needs and AI capabilities.
Exactly. And that unique blend of communication and domain knowledge. It's commanding an average 23.8% salary premium.
Wow. Okay. And what about addressing those security and quality concerns we just talked about? Are there specific roles emerging for that?
Yes. Dedicated AI validator positions are popping up. These specialists focus solely on checking AI output against security best practices, against that crucial contextual domain knowledge.
So human gatekeepers for the AI fire hose.
Pretty much. And they're proving effective. They achieve 31.7% higher detection rates for quality issues and vulnerabilities compared to just traditional peer review.
So that's the organizational investment needed to actually leverage the speed safely.
It is. The human role shifts. Less pure creator, more curator, critic, architect, validator.
So the developer of 2026, less keyboard jockey, more creative problem solver, architect, skilled prompt engineer, security validator, all rolled into one. It sounds like a much higher leverage role, more intellectual maybe.
That's the key takeaway, I think. The future is human-AI collaboration.
Mm-hmm.
But it only works if the human side brings the critical thinking, the context, the security focus, and that rigorous validation.
Okay, so the speed gains from AI are huge, but it all depends on the tools, right? The underlying programming languages we use. They need to be modern, safe, not ancient or insecure.
Exactly. So let's shift gears and look at the languages actually building this collaborative future. And the first thing to grasp is you can't just look at one metric for popularity. It's misleading.
Right. Metrics aren't monolithic. You need context.
Definitely. We look at roughly three main signals. GitHub's Octaverse that tracks active contributors. It shows where people are actively building, innovating. It's the momentum signal.
Okay.
Then Stack Overflow survey. That captures adoption and sentiment, what people say they use, and importantly, what they like using.
Got it. Developer mindshare.
Yep. And finally, TIOBE. That tracks search interest, which is a pretty good proxy for curiosity, hiring demand, what people are looking up.
Okay, so combining those signals, we should get a clearer picture of the real winners, the ones with momentum. And you said there's a new number one by a key metric.
There is, and that distinction goes to TypeScript. TS officially jumped to number one on GitHub Octaverse by active contributors.
Number one by contributors. That's big.
It's huge.
Yeah.
And it's not a small jump. It reflects this massive accelerating surge. A plus 66% year-over-year contributor growth.
66% growth year over year. That's incredible momentum. What's driving that explosion?
It's really a convergence of a few key trends. First, just the ergonomics of types. Adding types to JavaScript solves so many of its historical pain points, brings safety and clarity.
Makes large code bases manageable.
Exactly. Second, its dominance in the front-end space is basically absolute now. And third, the rise of full-stack frameworks is making it almost mandatory.
Okay, when you say full stack frameworks,
Yeah.
you mean things like Next.js, TRPC. Why do they make TypeScript so essential?
Great question.
Yeah.
So frameworks like Next.js, they blend front-end and back-end logic into one cohesive developer experience. TRPC takes it even further.
How so?
It lets you define your back-end API functions, right? And then you can call them directly from your front end with complete end-to-end type safety.
Ah, so if I change an argument on the server,
The client-side code immediately throws a compilation error before you even run it.
wow, that immediate feedback loop. Huge reduction in runtime bugs.
Precisely. It makes TypeScript indispensable for complex, fast-moving apps.
Okay, TypeScript number one by contributors. Who's the other big winner? Still Python, I assume?
Yep, Python is the other undisputed winner, still surging. Its growth is almost entirely fueled by that AML, data science, and now the AI agent boom we talked about earlier.
Right, the language of data.
It is. It's ease of use, massive library ecosystem. It just remains the engine of the data world. Adoption is up another plus 7 percentage points in the latest Stack Overflow survey. Ranks number 2 on GitHub by contributors. Python is where insights and experiments happen.
Okay, TS and Python leading the pack. But the really interesting strategic challenger, the one making serious noise in the enterprise,
Yeah.
that's Rust, right? Moving beyond its systems niche.
Absolutely. Rust is moving aggressively from that specialized niche, loved by systems programmers, into an enterprise powerhouse. And the story here is all about safety and security.
Ah, linking back to our AI vulnerability discussion earlier.
Directly. Rust is meticulously designed to eliminate entire classes of memory-related bugs. Things like buffer overflows, use after free errors, the stuff that has plagued C and C++ code bases for decades.
And it does this without the performance hit of a garbage collector, like in Java or C#.
That's the magic. Memory safety without sacrificing performance. That combination is becoming mandatory for critical infrastructure.
So is this rise purely about performance, or is it really a security mandate coming down from, like, CISOs and risk officers?
I'd argue it's a security mandate disguised as a performance choice. The adoption data really reflects this safety imperative. In system programming, Rust's adoption rate jumped from 1.05% in 2024 to 1.47% in 2025.
Okay, that might sound small, but percentage-wise.
It's a massive 40% relative increase in just 1 year. And crucially, This shift means Rust is actively overtaking C in adoption rate for new system-level projects. The migration is really starting.
And it's not just grassroots adoption. We're seeing official endorsements, too.
We are. The U.S. Cybersecurity and Infrastructure Security Agency, CISA, specifically recommended organizations move away from CC++ towards memory-safe languages, like Rust, to mitigate those systemic security risks.
Wow. When government agencies start saying that.
It signals a major shift in enterprise thinking and procurement.
So what are the prime enterprise use cases driving this Rust adoption?
It's ideal for anything high performance and security critical. Think high-speed web services, cloud infrastructure tools like parts of Kubernetes or service meshes embedded systems.
Makes sense.
And it's also kind of the dark horse of the AI race. Not for writing the models themselves usually, but for powering the high-performance infrastructure that runs those large AI models incredibly quickly.
Interesting. But you mentioned it rarely works in isolation. How does that play out in big companies with massive CC++ legacies? They can't just rewrite everything overnight.
No way. That leads to the coexistence model. The key is incremental migration using something called the Foreign Function Interface, or FFI.
FFI. Okay, what's that in simple terms?
It's basically a standardized bridge. It lets code written in one language, like Rust, call functions, or use data structures from a different language, like C or C++ American. Think of it as a universal translator and handshake protocol between languages.
Ah, okay, so you can swap out pieces.
Exactly. Developers use Rust's FFI to incrementally rewrite specific modules, maybe the ones most vulnerable or performance critical within a larger C++ application.
So you replace a risky C module with a safe Rust one, and the rest of the app doesn't even notice.
Pretty much. It allows risk mitigation and performance gains without that terrifying multi-year forklift upgrade. It emphasizes coexistence.
That makes the adoption path much, much clearer and lower risk. Okay, moving on from the big winners and challengers, what about the steady hands? Any surprising resurgences?
Yeah, two quick but important ones. First, SQL is seeing a massive comeback signal. It actually re-entered the TOBE top 10 rankings in October 2025.
SQL. Really, back in the top 10.
Yep. And it reflects a simple truth. Data is the new app surface. With AI and analytics dominating everything, the ability to define, retrieve, manipulate structured data is central again. SQL's clarity, its declarative nature, is becoming critical, especially for things like defining feature stores for AI models.
Interesting. Data skills are core skills again, and the second steady hand.
The foundational layer. The essential plumbing, shell scripting bash, shish. It remains stable, foundational. It's the backstage workhorse of automation.
For DevOps, CI/CD pipelines.
Exactly. Managing container entry points. It's not flashy, but it's the silent layer ensuring all that automated deployment stuff actually works reliably. Shell scripting isn't going anywhere.
Okay. Finally, let's touch on the legacy languages facing challenges, starting with the old heavyweights, C and C++.
Yeah, C and C++ are volatile. Still core, still absolutely necessary for specialized domains like embedded systems, high-performance computing.
PC, yeah.
But C's overall share fell from about 11% down to just under 10% in the past year. And that entire decrease seems driven by the security concerns that Rust is addressing so effectively. For general application development, their relevance is definitely eroding.
Okay. And then there's PHP, still powering a huge chunk of the web,
But it continues its long-term slide in share.
Yeah.
Yes, it powers massive legacy ecosystems like WordPress, but in the broader enterprise and startup world, it just lacks the modern momentum of TypeScript or Python.
And the salary data reflects that too, doesn't it?
It does. Statistically, it's generally considered one of the lower paid languages, reflecting its sort of relegation to maintaining older platforms rather than building cutting-edge new ones.
Right. And speaking of outdated perceptions, the myth of the super high-paid specialist COBOL programmer, that still persists sometimes. Is there any truth to that? Is it a hidden gold mine?
Our sources strongly debunk that myth.
Yeah.
We need to be clear here for anyone maybe thinking that's a path. In reality, yes, COBOL expertise is scarce. But the jobs, they're often highly stressful, surprisingly poorly compensated maintenance roles.
Really? Not lucrative.
Generally not. You're usually dealing with brittle, ancient legacy systems, often in finance or insurance. The work is frequently subcontracted out to keep costs down. You're fighting dense, often uncommented, boring code bases, with basically zero opportunity for modern development practices or growth.
So the pay isn't actually better, despite the scarcity.
Often worse than other programming jobs. It's a challenging domain, maybe even a necessary one for a time, but it's definitely not some lucrative hidden secret.
Good to clarify that. So the language picture for 2026 seems pretty clear then. Go with typed languages like TypeScript for general purpose, Python for data and AI, and increasingly Rust for systems and performance where safety is paramount. That looks like the winning trifecta.
That sums it up pretty well.
Okay, we've covered the languages and who's writing the code, humans and AI collaborating. Now, how are we structuring that code? For the last decade, it felt like the answer was always absolute distribution. Microservices, microservices, microservices.
Yeah, that was the mantra.
But that approach seems to have hit a serious wall, a complexity ceiling. We're hearing a lot about microservice fatigue now.
That fatigue is absolutely real. It's widely documented by 2025. Look, microservices were revolutionary, right? They solved real problems with the old monoliths, letting teams use different tech, deploy independently.
Organizational scaling, yeah.
But they introduced this massive new layer of complexity. And for many organizations, that complexity just started outweighing the original benefits.
What were the specific pain points? Why did the pendulum start swinging back?
The complexity just ballooned, tracking dozens, sometimes hundreds of services. It requires huge operational effort. You need service meshes, distributed tracing just to figure out what's going on, incredibly complex DI/CD pipelines.
Right. The operational overhead became crushing.
And critically, many of those microservices ended up tightly coupled anyway, just coupled over the network instead of within the same process. So a change in one still broke another, just in a less predictable way.
And the performance hit from all those network calls.
Exactly. Network latency is a killer. A single front-end API call that might have been a quick function call in a monolith could suddenly explode into dozens, even thousands of internal RPCs bouncing across the network.
That just crushes performance and makes debugging a nightmare.
Totally. And then throw in complex data consistency issues trying to keep data synchronized across multiple services. That was often the final straw for many teams.
Okay, so if microservices caused fatigue, what's the consensus now? Are we just going back to the big ball of mud monolith?
Not the old monolith, no. We're seeing a strong embrace of the modular monoliths, like the elegant new middle ground.
Modular monolith. Okay, unpack that. How is it different?
It's still a single deployed application. One code base, one runtime. But internally, it's structured into well-separated, distinct modules with really clear boundaries, often guided by principles like domain-driven design.
Ah, so you get the organizational benefits, clear domain separation, but without the operational nightmare of distributed systems.
Precisely. You keep the simplicity, one code base to manage, one thing to deploy, one set of local tests that run fast. But you gain that internal organization and clarity because modules can't just randomly call each other. They have to go through explicit, defined interfaces.
And calls between modules are faster.
Way faster. They happen in process, measured in nanoseconds, not milliseconds like network calls. They can often be type-safe if you're using something like TypeScript, and they're infinitely simpler to test and deploy than complex network RPCs.
So for many businesses, this is the sweet spot.
For probably 80% of businesses, the modular monolith is the smartest starting point. You get most of the benefits of microservices without most of the pain.
Okay, that makes sense. But some workloads do need to be distributed. For those, is the approach changing too? We're hearing a lot about event-driven architecture.
Yes, event-driven architecture, or EDA, is definitely the preferred approach now for achieving true loose decoupling when you do need distributed services.
How does that work? Instead of direct calls.
Exactly. Instead of Service A directly calling Service B, which creates that tight dependency we hate, Service A just publishes an event, a notification, something like order placed. It shouts it into the void, essentially.
Okay.
And then any other service that cares about that event, maybe Service B, inventory, Service C, shipping, Service D notifications, they subscribe to that order-placed event stream.
So things like Kafka or Pulsar become the central nervous system, the message bus.
That's a great analogy. The streaming platform is the central nervous system. And this makes the whole system incredibly resilient.
How so?
Yeah.
Because services don't depend directly on each other.
Right. Components can fail, they can scale independently, you can upgrade them. As long as the events keep flowing onto that central bus, the system can adapt. If the inventory service goes down for an hour,
The order service doesn't care.
nope, it just keeps publishing order-placed events. When inventory comes back up, it just starts processing the backlog of events. That's true resilience and loose coupling.
Okay. EDA for distributed systems. Makes sense. Now, shifting from logical architecture to the runtime, WebAssembly. WAS
Yeah.
seems to be making waves outside the browser now.
Huge waves. WASM is becoming a universal runtime environment. It's fundamentally changing how we think about portability and efficiency.
How does it work? You compile code from different languages.
Right. Code written in Python, Go, Rust, C++, May, whatever, gets compiled into this secure, compact binary format. And that WASM binary can then run almost anywhere, servers, edge networks, IoT devices, without modification.
How does that compare to containers like Docker? Isn't that the standard for portability?
It is, but WASM offers some key advantages. It's generally faster to start up, lighter in terms of resource usage, and arguably more secure by default
More secure. How?
because of its sandboxed execution model. WASM modules run in a very restricted environment with capabilities explicitly granted, providing strong security isolation between components almost automatically.
And the resource usage.
Significantly lower than traditional virtualization or even containers sometimes. Specialized WASM runtimes can start in milliseconds, even microseconds, and they can scale down to 0 when idle, using no resources.
Wow, milliseconds. That's huge for things like serverless or edge computing.
Exactly. That ultra-low resource use and fast startup make it incredibly efficient, especially where resources are tight, like on-edge devices.
Okay, one more architectural shift. Databases. It feels like the old lines between relational and NoSQL are getting blurry.
They absolutely are, driven by developers wanting the best of both worlds, flexibility and reliability. On one side, you've got NoSQL databases emerging.
NoSQL,
Yeah.
it's their promise.
They promise the massive horizontal scalability that NoSQL pioneered, but with the strong consistency guarantees of traditional relational databases, specifically ACID guarantees.
Okay, quick refresher for listeners. ACID.
Sure, ACID stands for atomicity, consistency, isolation, durability. The 4 pillars guaranteeing reliable transactions, preventing data corruption when lots of things hit the database at once.
Got it. Like bank transfers, they either happen completely or not at all.
Exactly. Atomicity. Consistency means the database always stays in a valid state. Isolation means concurrent transactions don't mess each other up. Durability means once it's saved, it stays saved, even if the system crashes.
So NoSQL gives you that rock-solid reliability plus web scale.
That's the goal, solving a decades-old trade-off.
And on the other side of the spectrum, more flexibility.
That's the rise of multi-model databases. These systems support different data models like document, graph, key value, all within one database engine.
So you don't need a separate graph database just for social network features or a separate document DB for JSON blobs.
Right. It simplifies the data architecture dramatically. You can handle different data shapes and relationships within one system.
And how we talk to these databases is changing too, influenced by things like GraphQL.
Yes. GraphQL's philosophy, asking for exactly the data you need, no more, no less, is heavily influencing new query languages and data access patterns.
Avoiding that overfetching problem common with older REST APIs.
Exactly. Which is crucial for performance, especially on mobile or slower networks. You fetch just the fields you need across potentially multiple data sources in one go.
Okay, so these architectural shifts, modular monoliths, ED, YSM, new database types, they all need a modern operational environment to run effectively, securely, efficiently.
Absolutely. The infrastructure has to keep pace.
And increasingly, that environment isn't just built by traditional ops or even DevOps teams, but by specialized platform engineering teams. This feels like a really big trend.
It's arguably the biggest story in ops excellence right now. Platform engineering is all about creating a robust, efficient ecosystem for developers, usually called an internal developer platform or IDP.
IDP, okay. And the goal is self-service, productivity.
Exactly. It's about providing developers a paved road, a shortcut to productivity, by abstracting away the underlying operational complexity. They shouldn't need to be Kubernetes experts just to deploy a service.
Right. But we already have DevOps, we have SRE, site reliability engineering. How does platform engineering fit in? Is it different or just a new name?
It's a crucial distinction, actually. DevOps is more about the culture and collaboration between dev and ops, breaking down silos.
Okay.
SRE is about applying software engineering principles to infrastructure, focusing on reliability, scaling, automation through code.
Right. Treating infrastructure as software.
Exactly. Platform engineering is distinct again. The platform team builds that standardized self-service environment, the IDP. Think of it like this. The platform team builds the highways and the guardrails. The feature teams, practicing DevOps, drive their applications quickly and independently on those highways. And the SRE team keeps the highway infrastructure running smoothly and reliably.
That's a helpful analogy. Okay, so what are the key practices or components that make up a successful IDP, this self-service platform?
Two critical practices stand out, both focused on automation and security. First is GitOps.
GitOps, using Git as the source of truth for infrastructure.
Precisely. It standardizes configuration by making Git the single source of truth for the entire desired state of the environment: infrastructure, applications, policies. Automated systems constantly reconcile the actual state in the cluster with the desired state defined in Git.
So if someone makes a manual change.
The GitOps system detects the drift and automatically reverts back to what's defined in Git, ensures stability, consistency, and provides a perfect audit trail.
Okay, GitOps for configuration. What's the second key practice? You mentioned security.
That's policy as code, or PAC. This directly addresses those security and compliance concerns we keep circling back to.
Shifting security left into the development process.
Exactly. Instead of manual checklists or finding problems late in the cycle, PAC uses tools. Open Policy Agent, OPA, is a common one to encode security rules, compliance requirements, best practices directly into the deployment pipeline as code.
Like what kind of rules?
Things like, all Kubernetes ingress controllers must use HTTPS, or container images must be scanned for critical vulnerabilities before deployment, or maybe only the SRE team group can deploy to the production namespace.
Ah, so it automates enforcement, catches issues before they get deployed.
Right. Security becomes automated guardrails, not a bottleneck slowing down delivery speed.
Okay, GitOps and policy as code underpinning the IDP. Now let's zoom in on a specific type of infrastructure where a lot of modern workloads, especially AI, are landing. Serverless AI. Seems like the default for unpredictable compute needs now.
It really has become the default, especially for inference workloads. Serverless mostly function as a service, FaaS, which holds, 64.8% of the serverless market share, is perfect for AI.
Why AI specifically? The elasticity.
Exactly. That high elasticity combined with the pay-per-use model makes the economics incredibly compelling. You only pay for the milliseconds of compute time when you're actually running an inference, not for idle GPU clusters.
So what are the headline economic gains? We talking significant savings.
Oh yeah. Organizations using serverless for AI report an average 42.3% reduction in total cost of ownership, TCO, compared to traditional always-on deployments.
42% TCO reduction, that's huge.
And for workloads with really spiky variable load, those savings can hit peaks of 52.4%. Plus, there's a time-to-market benefit. Medium-sized businesses using this see around a 67% reduction in time to market for new AI features because the infra setup is so minimal.
Wow, transformative efficiency. But there's always a but. We have to talk about the Achilles heel, the cold start challenge, especially with big AI models.
Yep. Still the critical limitation. A cold start happens when a function hasn't been invoked recently. The platform has to spin up the environment, load the runtime.
And for AI, load that potentially huge multi-gigabyte model into memory, maybe onto a GPU.
Right. That takes time. It's like preheating the oven every time you want to bake a single cookie. If your model is massive, that preheat time can be significant.
How significant are we talking? What kind of latency does this add?
For complex AI workloads, cold start latency can range anywhere from 900 milliseconds up to 3.8 seconds. We've even seen reports of up to 6.2 seconds for really large deep learning models.
6 seconds. That's an eternity for a user waiting for a response.
It is. And here's another critical factor. Adding enhanced security configurations like running the function inside a private network, VPC, increases that cold start duration by another 52.3% on average.
Ouch. So security adds latency. A tough trade-off.
It really is.
Okay, given these cold starts and trade-offs, how do the major cloud platforms actually compare for running serverless AI? Does it depend on the model?
It definitely depends. Recent benchmarks give us some pretty clear guidance, though. For more general, lightweight inference tasks, like using a standard ResNet 50 model for image classification,
Yeah.
Google Cloud Functions, GCF, tends to show the lowest average inference latency, around 112 milliseconds once it's warm. Their architecture seems optimized for really fast startups for smaller functions, plus they offer great GPU support T4s, P4s, A100s.
Okay, GCF for speed on lighter models. What if you have a really big memory-hungry model?
That's where AWS Lambda often pulls ahead. While GCF is fast, Lambda offers configurations with much higher memory limits, up to 10 gigabit per function, essential for those giant models.
And AWS has something specific for cold starts too, right? Snap start.
Yes, SnapStart. It's made huge strides in mitigating cold starts, especially for Java runtimes initially, but the principle is expanding.
How does Snap start work? It doesn't just start from scratch.
Right. It takes a snapshot of the initialized execution environment after the slow parts are done, the runtime's loaded, maybe the model's partially loaded. When a request comes in, instead of starting cold, it restores that warm snapshot almost instantly.
Bypassing the slowest steps.
Exactly. And the data shows this can reduce cold start times by around 65.4%. A massive improvement.
65%. Okay, so it's a strategic choice then. Model size, cost profile, can you leverage SnapStart? Can you give us a concrete, real-world example of serverless AI delivering serious business value beyond just TCO numbers?
Sure, let's look at logistics. A big global logistics company moved their complex route planning and package distribution algorithms, which have hugely unpredictable demand, especially around holidays, onto an event-driven serverless architecture.
Okay.
By doing this, they could instantly scale those compute-heavy algorithms during peaks without paying for idle servers the rest of the year. The result? A 28.4% improvement in overall route efficiency.
28% is huge in logistics. What did that translate to financially?
It translated directly to about $12.8 million in annual fuel savings. Better routes, less driving, denser deliveries. The ROI on operational efficiency can be enormous.
$12.8 million. Okay, that makes the case pretty clearly. Which makes the future trends in serverless AI, looking out to 2030, even more interesting. They're actively trying to kill that latency problem, right?
They are. The research is pushing towards even more granular efficiency. We're starting to hear about nanofunctions.
Nanofunctions, smaller than FIs.
Much smaller. The idea is instead of a whole function running an entire model inference, a nanofunction might just execute one specific component of the underlying computational graph, like a single layer in a neural network.
Ah, so much more fine-grained execution.
Exactly, which allows for incredibly precise resource allocation. Projections suggest this could lead to maybe a 37.8% reduction in overall execution time for complex models, just by optimizing the scheduling of these tiny pieces.
Interesting. And the ultimate goal, eliminating cold starts altogether, is that even possible?
That's the moonshot. Intelligent resource management baked into the platforms themselves, using AI to forecast workload patterns.
AI predicting demand for AI workloads. Meta.
Totally. Predictive scaling algorithms are getting really good. They're expected to hit 92.4% accuracy in forecasting typical workload spikes by maybe 2027.
92% accuracy. So the platform could pre-warm resources before the traffic hits.
Precisely. Proactively spin up instances, pull down models. The projection is this could eliminate the cold start penalty for something like 86.7% of invocations under normal patterns.
86.7% elimination. If they hit that, it basically nullifies the biggest drawback of serverless AI today.
It would be a massive shift. It would pretty much guarantee FAS dominance for a huge range of applications.
Wow.
Hashtag outro.
Wow. Okay, so we've covered a ton of ground. The entire stack, really. From AI code generation and its security risks to the winning languages, the architectural shifts like modular monoliths and EDA, all the way down to platform engineering and the future of serverless AI, all based on the latest signals.
It's a lot to take in. For you, the listener, the key really have to be balance. Strategic thinking. You don't need to chase every single shiny new thing.
Oh, no.
But you absolutely must understand these fundamental structural shifts that are happening.
The strategic approach seems to be start simple where you can, embrace that modular monolith first, get your domain boundaries right before jumping into microservice complexity hell.
Definitely. And view AI as that collaborator. A
Yeah.
powerful tool for speed, for handling implementation details. But remember, prompt engineering is key to getting quality contextual output. You have to guide it effectively.
And underpinning all of it, prioritize safety. Leverage memory-safe languages like Rust where it makes sense. Solidify your infrastructure with platform engineering best practices like policy as code. Build those guardrails.
So maybe we can give some focused, actionable advice based on roles looking towards 2026.
Good idea. Okay, if you're primarily a front-end or full-stack developer,
Your mandate is clear. Master TypeScript. Go deep on server-side TS patterns too, especially with modern frameworks like Next.js, TRPC. That end-to-end type safety is invaluable.
all right, if your world is data or AI,
Keep doubling down on Python, obviously, notebooks, core libraries, but also really sharpen your advanced SQL skills. With data being the new app surface, being able to effectively query and manipulate structured data is crucial again. Don't just rely on ORMs.
good point. Okay, for systems or performance engineers.
The focus is safety and speed. Invest heavily in learning Rust. Understand its memory safety guarantees, its performance characteristics. But crucially, pair that with FFI knowledge how to interoperate with existing C++ code bases. because coexistence is the strategy for large systems.
Makes sense. And finally, for cloud or backend developers in general.
The winning combo often looks like Go or TypeScript Node.js, leveraged within serverless and event-driven patterns. And increasingly, platform engineering skills are essential. Understanding how to build, maintain, and use that self-service IDP effectively is becoming a core competency.
Okay. We started off saying the software landscape is unrecognizable compared to 5 years ago.
Yeah.
I think the data we've discussed really bears that out. It points towards a future that's potentially much more collaborative, safer, maybe more efficient.
If we apply that critical human judgment, that oversight, that context, that security focus.
Right. Which leads us to maybe a final provocative thought for you, the listener, to take away.
Go for it.
The most successful companies, the most successful engineers in 2026. They'll likely be the ones who see these massive technical shifts, AI handling the how, the complexities of distributed systems, not just as problems to solve with more code, but as opportunities. Opportunities to apply distinctly human creativity, deep domain knowledge, architectural thinking to entirely new levels of problems. If AI can handle more of the implementation grunt work, the how, what higher level, more complex, more valuable business problem can you define and solve next?
That's the multi-million-dollar question, isn't it? What do we do with all this leverage?
A question worth wrestling with as you plan your own strategy. Thank you for joining us on this deep dive into the 2026 software stack.
Yeah, thanks for tuning in. We hope this shortcut through the noise helps you make your next big strategic bet.